Oh, hi there. Thank you so much for showing up for your learning. It's Mr. Jennings, and we are looking at the third section of the practice quiz, which is all about rational expressions. So algebraic expressions and solving equations, this type of stuff. So here's how I recommend you use these videos, okay? Try these questions yourself, and then tune in, watch the video. Use the video to get unstuck, okay? Use the video also to see how I do these, and that's going to help you do them the same way I do, which is of course the best way, because of course it's the best. Okay, lots of ways to do this first one here. We want to know what a is. Our goal is a equals some number. If you know 13 minus 5 is 8, then you know the answer is 5. Yay! But you can also do this. Subtract 13 from both sides, and then we get negative a is equal to negative 5, and then we flip the sign. A is equal to 5, and we're done. That's what an answer looked like. Here we have 5 multiplied by b is 35, so we're going to divide both sides by 5, because that's the opposite of multiplication. And that gives us b is equal to 7. It's amazing. It's beautiful. There we go. That's how that one do. All right. This one over here, we're dividing. So the opposite of divide is multiply. So let's multiply both sides by 10. Okay? I'm going to multiply that by 10. So c is equal to negative 70. Okay, because negative 7 times 10 is negative 70. That's done. So you just use the opposite. Just use inverse operations. You can solve these. With these ones, we're going to use inverse operations, but we have 2 steps to do. So if I want to know the value of d, this would be subtract 8 from both sides. Gives us 3d equals 15, because this gone is 0. And now we divide. Okay, divide both sides by 3. D is equal to 5. Over here, well, I can subtract 17 from both sides. Gives me negative 21 is equal to 3f. And then I divide both sides by 3, because division is the opposite of this multiplication. And I get f is equal to negative 7, because that's what that is. F is equal to negative 7. Circle it. Final answer. All right, over here. Let's add. Let's add 2 to both sides. Okay. Then we get g over 3 is equal to 60. And then I'm like, wow, I'm dividing. What's the opposite of dividing? It happens to be multiply. Multiply is the opposite of dividing. So I'm going to multiply by 3 on both sides. 18 plus 2 isn't 60, is it? It's 20. I just looked at it and knew the answer. Okay, so g is equal to 60, because that's 20 times 3. There, done. Final answer. Okay. And then we keep going. Over here, these ones are tricky in that we have h. We have our unknown on both sides of the equation. But our goal is the same, folks. Our goal is still to have h is equal to some number. So I'm going to add an h to both sides to give me 4h minus 5 equals 3. And then I'm going to add 5 to both sides. Give me 4h equals 8. And then, gosh, I can see it now. H is 2. H is 2 there, because I divided both sides by 4. And 8 divided by 4 is 2. That's how that one do. Over here, oh, I got j over 9. So I'm going to add j on 9 to both sides. So that's like saying 3j on 9, that's this, multiplied top and bottom by 3, so I get a common denominator, plus j on 9 plus 4 is equal to 12, okay? So that's 4j over 9, minus 4 both sides, is equal to 8, okay? But that's not final answer. I'm just going to move that. See, I subtracted 4 from both sides here. So that's 12 minus 4 is 8. And so then, I got 4j over 9 is equal to 8. I can multiply both sides by 9. So that will cancel. 4j is equal to 72. Divide both sides by 4. Okay? And 72 divided by 4 happens to be 18. So j is equal to 18. Then I can check it too, right? I can always check these. if I put this up here, j divided by 3, let's highlight as I go, j divided by 3, that's 18 divided by 3, that's 6. 6 plus 4 is 10. Well, is that the same thing as 12 minus 18 divided by 9? 18 divided by 9 is 2. Yes, it is. So that's true. Cool. All right, let's keep going. Now we've got distribution to interest us. So here I need to multiply these in. Okay? This will give me 6k minus 15 is equal to, multiply this in, 105 minus 14k. So in order to tidy this up, I'm going to add 14k to both sides. So I get 20k minus 15 equals 105. And then I add 15 to both sides, because that's going to clear that away and make a simpler problem. 20 times k is equal to 120. I happen to know when I divide that by 20, that's going to be equal to 6, which is equal to k, right? Because this cancels, that's k. K is equal to 6. Done. Final answer. Okay. Over here, we've got a negative number that we want to distribute in, okay? So that's going to be negative 15m. Negative 5 times negative 9 is positive 45. Common error, watch out for that, is equal to 15 minus 3m. Don't forget to distribute both sides. We're going to add 15m to both sides. And subtract 15 from both sides. We got 30 is equal to 12m. Divide both sides by 12. 30 divided by 12. 30 divided by 12 happens to be 6 on 3. Wait, no, what? No, we can't say 6. 5 on 2. 5 on 2. 5 on 2 is what we're left with, is equal to m. That's done. Final answer. Yes, your answers can be fractions. In fact, they frequently will be. All right, let's do this one. Okay, solve for this unknown. Oh, I see that I have some like terms that I can do. Okay, I got 3n minus 5n. So it's going to be negative 2n plus 3 plus 4. Plus 3 plus 4 is plus 7 equals 3. Okay, now I can subtract 7 from both sides. So I get negative 2m equals negative 4. Divide both sides by negative 2, because I'm multiplying by negative 2, so I do the opposite, which is divide by negative 2. That gives me m is equal to 2. And that's true. M is 2 is true. Up there, at least. Okay. Another one. Oh, this one's got distribution. It's got collect like terms. It's got all the goodies. It ain't got no fractions, though, because I ain't playing you that way today. Okay, 3 distributes in, so that's 3p minus 3. This negative 2 distributes in, so that's negative 4p minus 14 equals p minus 10. Collect our like terms. We have negative p, when we take the 3p and the minus 4p, put them together, minus 17 equals p minus 10. Add 10 to both sides, and add p to both sides. This gets all my numbers to one side over here for minus 7. That's minus 7 is equal to 2p, because this is 0 as well, and this is 2p. Divide both sides by 2. Negative 7 on 2 is the final answer, so I'm going to write negative 7 on 2 is equal to p. There we go. Very cool, eh? Very cool. Now, let's go. You want to be in this video asking, go to your locker? Yes, you may go to your locker. De rien. Au revoir. À demain. À bientôt. Okay, so now, we have been told that the perimeter of this shape is equal to 26. Oh my goodness. I know the whole way around that an ant would walk if it walked around this shape would be 26 somethings. And I've been asked to find W. Now, let's see. What is the perimeter? Well, the perimeter is going to be all the sides added. So let's add all the sides. Okay, I got w plus 5 and w plus 5. I have two of those. So that's 2 multiplied by w plus 5. And then I got w minus 2 4 times. So that's plus 4 w's minus 2. After I do distribution, that's 2w plus 10. And this is 4w minus 8. So that gives us 6w minus plus 2. And I've been told that the perimeter is 26. So 26 is equal to 6w plus 2. See, I can build an equation. And then by solving this equation, I find the mystery value w. So I'm going to subtract 2 from both sides. 24 is equal to 6w. I divide both sides by 6. Home stretch, everyone. W is equal to 4. Circle it. Final answer. Write a simplified expression for the area of this one.
I would not recommend eating whiteboard marker.
I feel like I'm going to start class and let people approach me and ask me about this, the only spicy question on the test. This is the only spicy one on here. And I could answer it right now and help you out. Or I could get started with class. Let's take a vote. Should I do this question as part of the video, or shall I pay all of you attention now?
Do the question.
Do the question? Do you want me to put it up there so everyone can see?
Yeah.
Okay. Could my lovely assistant erase the board while I plug in here? And I'll sing the Glade plug-in song.
Why are you eating it?
Because I can never resist a jingle. Plug it in, plug it in. All right. Oh, and let's turn this on. For those of you hanging out for this part of the video, I salute you for showing up and being here for the long haul for your math learning. Oh, hi everyone. Thanks so much for showing up for your learning. You may begin your review for Thursday's test, but I am finishing the review. I'm just the very last question of the review, and then I will get it printed off for you all so that you may use the video. And how do you think you're going to use these videos, use this review package? What's your strategy? Oh, hey, Mr. Jennings, I'm going to try these questions myself. I'm going to get real confident on some of them, and then I'm going to get confused on others. Those confused ones, I am not going to put the test under my pillow and hope that I absorb it at night. I am going to come and ask you about it either at lunch or in class Monday, Tuesday, or Wednesday. I will not ask you about it in class on Thursday, Mr. Jennings, because I know that I'll be writing the test on Thursday, so I might as well ask the furniture a question, because you're not very helpful during tests, Mr. Jennings. You're about as helpful as the furniture. In fact, less so, because I can't use your back to write the test on. So the furniture will be more useful to you on Thursday than I will be. But I will be as useful as I can possibly be Monday through Wednesday. Make sense? Cool. Okay. This one is a little different than questions that we've seen, but it was very similar to the patio type question. And I put it in here into the practice quiz because they're doing types of questions like this in the other class. And I want to show you that, yes, you can do them with the math that we've looked at. It's just a little bit unfamiliar. You haven't seen it yet. So we've been told that there's this shaded area here. Maybe it's a deck with two holes, like there's a hole and there's a hole. And I want the area of this deck. For some reason, whoever put this question together wrote 1x and 1x, which makes me like I need a bucket. Bring me the bucket so I may barf. No, it's just what they've done, so whatever. So I have the total area is going to be equal to the big rectangle minus hole 1 minus hole 2. Okay, so here's hole 1 and here's hole 2. And I'm going to create an expression that shows the area of all of these different rectangles. Okay, I know that rectangles have an area that's equal to length times width. So I'm just going to do that. Here, let's call this the width and let's call that the length because reasons. Okay, so that I get this. 4x multiplied by 10x plus 7. Okay, and then I'm going to take away this whole here, whole 1, which is 2x times 2x plus 3. So it's going to be minus 2x times 2x plus 3. Minus whole 2, which is 1x times 1x plus 4. Minus x, that's 1x. You won't catch me writing down 1x. My goodness, the math police would come and math me away to math prison. Okay, so now I have an expression. It's not simplified yet, but this expression will give me the area of that shaded bit. It's just the big rectangle minus the two small rectangles. Nothing too special yet. Okay, now we use the distributive property to evaluate, to simplify these things. So I have to multiply that 4x in. 4x times 10x. Wow, that's 40. 4 times 10 is 40. X times x is 2x's multiplying. That's x squared. And then 4x times 7, well, that's plus 28, because 4 times 7 is 28. X. Not x squared, not x to the 4, not the square root of x, just x. There's just one copy of x there, so it's x. And then we have minus 2x times 2x. That will be minus 4x squared. Minus 2x times 3. That will be minus 6x. Minus x times x, that will be minus x squared. And minus x times 4, that will be minus 4x. All right, we're almost there. Now we get to collect like terms, which is everyone's, at least in the top 5 of my favorite steps in this problem. Okay, so I'm going to count up my x squareds. I have 40 of them. Take away 4, take away 1. So I end up with 40 minus 4 minus 1 is 35 x squareds. They stay x squareds, folks. They don't change into something new. They're still x squareds. I have 40 of them there. I take away 4. I take away 1. That leaves me 35. And now I'm going to look for my linear x's. That's 28 minus 6 minus 4. So that's going to be 18. 28 minus 6 is 22. Minus another 4 is 18. There we go. And then I circle it. And I put a check mark. And I say, look at my answer, Mr. Jennings. You asked me for a simplified expression for its area. That's the simplified expression for its area. It can't be simplified further. I cannot put x squareds together with x's. They're not like terms. Next, I said, use your expression to calculate the area if x is 10. Oh, that's cool. All right, so now we know. We're told x is 10. So I'm going to put my 10 in there for x squared. And then I'm going to add 18 multiplied by my x in there. But x is 10, so I now just substitute that in wherever it's appropriate, okay? So let's go. Now I do this Bedma style. So this is still 35 multiplied by 10 times 10, and I happen to know 10 times 10 is 100. 18 times 10, well, I can just do that. That's 180. It's a very good score on 3 darts. And then this is 3,500 when I do this multiplication plus 180. That's 3680. There. Let's have a little statement. The area of the shaded region is 3680 when x equals 10. Oh man, if I see that statement after you do all that work, I am like, this is a student that knows what's going on. They know that this shaded area could have a wide variety of areas depending on the value of x. But when x is 10, it has exactly the area 3,680. And that's how this type of question do. And that's how you're going to do on Thursday when you're confronted with this, the absolute spiciest level of anything that I would throw at you on Thursday. Okay, the questions are going to come at you mild and milder in the beginning. And you're going to demonstrate that you know the general skills of working with integers, positive, negative numbers, adding, subtracting, multiplying, and dividing. You can work with fractions. You can add them, subtract them, multiply them, divide them. You don't get fooled by 3/4. You're comfortable with 75 cents. All right? You're going to show me that you can work with exponents. You're going to show me that you can solve for unknowns. You can use the distributive property. You can collect like terms. These are the skills that you will practice this week. Any questions? Hit me up during class, hit me up at lunch, hit me up sometime before the midterm test on November 7th there, okay? Hit me before that time, even lunch on that day. I'm going to be super helpful. As soon as the clock rolls over, it's time to start class. It's going to be like Mr. Jennings is more useless than furniture, all right? But before then, I hope to be more useful than your furniture at explaining math. Bye for now, everyone.